Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 2 of solving quadratic inequalities using the algebraic method. So if you've missed part 1, I'm going to link that video in the description box below. Please go ahead and take a look at it. In this video, we're going to solve a quadratic inequality that's less than 0, which means that after you factor that quadratic expression, the product of the factors is going to be negative. Let's start. This time, let's take an example where we have less than 0, okay? Because we're looking at both those algebraic principles that needs to be used, the product of two terms being positive and the product of two terms being negative. In this case, it will be negative. So first, let's factor the quadratic expression on the left-hand side. When we factor that, this is going to be, this is 4x square minus 8x plus 1x plus a 2 is less than 0, and that should be 4x, x minus 2 plus 1 times an x minus 2 is less than 0. Okay, this time it's less than 0, strictly less than 0, so we maintain that inequality. In the earlier example, we had greater than or equal to, okay? So maintain that kind of an inequality. So once we have this thing, we have the factors as x minus 2 times a 4x plus 1 is less than 0. Less than 0 means negative, and we said the product of two terms. What are the two terms here? That's one term. Consider that as one term A. And that's another term. Consider that as another term B. When will A times B be negative? Well, there are two cases again. What are those two cases? Case 1, when x minus 2 is greater than 0, and remember, within the case, it's an and, 4x plus 1 is negative. Remember, there should be an opposite signs. When the two terms are of opposite signs, only then will their product be negative. All right, that's the idea we've been using in both the examples so far. When we solve each of these linear inequalities now, you'll get x should be greater than 2, and is the operative word. 4x plus 1 less than 0 would give us x should be less than a negative 1/4. Now again, use the number line approach. All right, so when we have a number line, this is just a rough way to estimate what's going on. So if I have this is 0 and if this is negative 1, negative 1/4 should be somewhere there, just an estimate. And if that's a 1 and that's a 2, let's just mark this is strictly less than, strictly greater than 2. So it's an opaque, okay? Don't shade it, all right? So it's opaque. X greater than 2 should be on the right hand side of 2. X less than negative 1/4. Where's negative 1/4? It's here, again opaque, don't shade it, all right? It's on this side, less than. Now that doesn't make sense, right? Because when you're trying to have and, you're combining both the conditions with an and, you're looking for intersection. How can you have a number that's greater than 2 and less than negative 1/4 at the same time? Not possible. So this case, we say not possible. All right? I hope this makes sense, okay? Because what did we consider in this case? We took x minus 2 greater than 0 and 4x plus 1 less than 0. Why should they be of opposite signs? Because then and only then will the product of the two terms will be negative. But this is just case 1. Case 1. What's case 2? All right, let's write it down here. This is going to be my case 2. Can you see this? All right, case 2 is when, what are the two factors? X minus 2. I took in case 1 is greater than 0. So in this case 2, I'm going to take it less than 0. Okay, that's how we do that. Okay, if it's greater than 0 in case 1, less than 0 in the next case. And 4x minus 1, it's plus 1, should be positive. Opposite sign, okay? Correct. Okay, so now in this case, we're trying to combine these two factors with this sign, okay? Because in the first case, x minus 2 was positive and 4x plus 1 was negative. In this case, we reverse the signs. So now when we solve each of these individual inequalities, you'll get x should be less than 2 and, that's the key word, 4x plus 1 greater than 0 would give us x should be greater than a negative 1/4. Let's try and plot this on a number line and see what's going on, all right? So a rough estimate of these values, if that's a negative 1, that's a 1, and that's a 2. And remember, we have strictly greater than, that means we are not including the value, okay? That's why it's an opaque. And x less than 2 means it's all values on the left-hand side of 2, all right? X greater than, okay, let me mark that. What color did I use? All right, pink again. Negative 1/4. First, I need to identify where's 1/4, okay? This is just approximately, guys, negative 1/4, just to give us the idea, okay? Again, it's strictly greater than negative 1/4. Okay, so I'm not, I'm not shading that. And here we go on the right hand side. So now we have an intersection. And why did we need an intersection? Because that's combined with that word and. The intersection of these two are these values in between. So when we combine both the cases, basically, how do we combine? Well, this doesn't have a solution, right? This doesn't have a solution because there's no intersection. In this case, we have that combination, and the solution just comes from that case 2, which gives us the solution as x must be greater than negative 1/4 and strictly less than 2. And that is the solution to the inequality 4x squared minus 9x plus 2 is less than 0. Let's have a quick recap. What did we make use of? This was the main principle. This was the main idea, all right? When the product of two terms is positive, we have two cases. Both those terms must be of the same sign. When the product of the two terms is negative, both of those two terms must be of opposite signs. And that is how we interpret the sign greater than or equal to. Greater than or equal to should be interpreted as being positive. I said that even in the graphical method, okay? So when you factored the quadratic after collecting all on one side, if it needs to be, okay? In this case, we had to rearrange and collect all on one side. In the second case that we saw, it was already given on one side of the inequality. But in both cases, what did we do? We factored. After you factor, depending upon the sign of the inequality, if it's less than 0, then you put your cases that way, all right? That both of those factors must be of opposite signs. Solve each of those inequalities separately, put it on the number line to make sense. Remember this, okay? And that's intersection. Both the cases are combined by an or. That's the word that combines the two cases, but within each case, the combination must be and, which means the intersection. In the case of the negative, this and gave us no solution because there is no intersection. In the case 2 of the negative quadratic inequality, where x minus 2 was negative and 4x plus 1 was positive, there we found the solution to be the common region. As opposed to where the quadratic inequality was positive, remember here the two cases was both of them had to have the same sign. So when x plus 5 was greater than or equal to 0 and x minus 2 was greater than or equal to 0, combining them using the word and, the intersection, it came from one factor of each case. In case 1, it came from x greater than or equal to 2 because a number greater than or equal to 2 actually means it should be greater than or equal to negative 5. And in case 2, the solution came from x less than or equal to negative 5 because if a number is less than negative 5, it has to be less than 2 also. So the solution here is combining the two cases, x should be greater than or equal to 2 or x should be less than or equal to negative 5. I hope that this video was useful to you to understand how to solve quadratic inequalities using the algebraic approach. I'm going to see you all in the next video.